Hello. Today I'm going to be showing you how to automatically calibrate your PicoVNA using the new PicoVNA eCal devices. I've got one here in my hand. Before I do that, I'm going to kick off a manual calibration so that in part 2 I can make some comparisons of the quality of calibration between using the eCal module and the manual approach. So let's get going on that. You can see here I've got two male PC 3.5 ports that I wish to calibrate, and I've got one of our premium female calibration standards here. So let's get this underway. The first thing I have to do, of course, is to check which calibration kit I've got loaded to the VNA at the moment, and it's currently the eCal, so we want to do a manual cal, so we load kit 1, cal kits, and I'm using this one here, so let's load that. I only need to load that to port 1 because I'm doing a non-insertable calibration using just one calibration standard here. Okay, apply, close. So my setup is a full span sweep. I'm using 201 points. My IF bandwidth I'm using today is 100 Hertz. And we check that the correct cal is loaded, the correct kit is loaded to port 1 and port 2. We're going to do a non-insertable calibration with one calibration kit, and I begin with the load. Okay, so while he gets on with that, by the magic of video and video recording, we'll use our e-calibration device in parallel and see how we get on with this. Okay, so the short, open and load and through that we've done our manual calibration with, those parts are within, they're all within this module, along with microwave switches, so that we can automatically, over USB control, select the short, open, loads and throughs when we need to. The device also stores its own characterization data, so that is in there too, and can be read over the USB interface. Okay, so the first thing we do with our e-calibration module is that we plug it in, because this is a USB device, and as soon as I've plugged it in, you can see that it's gone into a heating condition, because this is an oven device. The standards, the short, the open, the load and the through within the device are ovened, so we need to bring those up to temperature. So that is now warming up for us. Let's begin the connection. Oh, look at that, it's all ready for us to use. Let's begin the connections. I'm connecting port A of the device to port B, port A of the device to port 1 of the VNA, and port B to port 2. And that's going to be important. We are going to have to remember that, or be aware of that, as we go through the calibration process. So there we are, we've got the device warmed and ready to use. So here we are. Our first action is to check the calibration kit that is loaded to the ports, and you can see we've got this is not an eCal module that is loaded to ports 1 and port 2 at the moment. So let's select electronic cal kit. So if we recall the connections that we made earlier, I connected port A to port 1 and I connected port B to port 2. So we're going to be using this interconnection detail. But I will just mention these other two. The eCal module is supplied with a little adapter, and you may be able to see that adapter has a little blue band at one end. So it's a marked, it's a polarized adapter, and this adapter has been characterized and comes with your eCal module, and it can be used in this configuration. The mark is and the adapter is applied with the mark towards port B, and I would then be able to calibrate an insertable calibration in which I have a male port on port 1 and I have a female port on port 2. Equally, I could fit the adapter with the blue band towards port B again, turn the whole thing around, and I could use this connection with the female port on port 1 and the male port on port 2 of the VNA. So 3 connections available for the e-calibration module as supplied with its adapter, and that's what those other connections are for. So let's find and load the EasyCal data, and there you go, it's found this module. The eCal has been loaded. It's reminding me that I must still apply that when I leave this menu. Okay, exit, apply the eCal module to port 1 and port 2. Close. Okay, we are ready to perform our calibration. So, and you'll notice we always check that the modules are indeed loaded. Port A to port 1 and port B to port 2. We're going to perform a non-insertable duct measurement because we've got 2 male ports, 1 cal kit, and all I need to do is start one of these operations here, and as you will see, the operation begins automatically. So now it's done its short on port 1 and open on port 2. That was short on port 2 and open on port 1. Load on port 1, load on port 2, and through. There we are, we're finished. Apply calibration. Start. There we are. So we've completed our calibration and we are indeed ready to make measurements. Okay, so my timings there did not include the kit file loading, but I did look at the repeated calibration process. And at 30 seconds, eCal beat manual cal by over 4 minutes. The serious point being that fast, accurate, convenient calibration leads to the most important benefit of all: regular calibration. Calibration wherever you really need it, and is not too disruptive that compromise might be a better option. For speed, for instance. 3 eCal purchase options are available from Pico in male, female, and a dual kit addressing both male and female test ports. The supported calibration types and lead configurations are shown just below on my slide there. Now, some of you might have noticed that I haven't really yet dealt with the accuracy of e-calibration relative to manual calibration. For that, we need to see part 2, please, and that is coming right up.